All right. My phone recording had a little glitch there. So here's part two. I was going to say afterwards that you could also write this as an end behavior. As x approaches infinity, f of x approaches 0. You could also say as the function goes to the right, it gets flatter. Okay, so flatter does not mean it gets lower. It means it's flattening out, not steepening. All right, moving on to number 7. Mr. Winger. Oh, that Mr. Winger tricked his parents into giving some money of their retirement income. They are now giving $5 a day on the first month and doubling his money each day for the entire month. Here's the function. So we give you a scenario for you to sort of get a context. Then we give you a function. Excuse me. Then we graph it. So now we're asking you just to interpret this graph and make sense of it. On the last day, and also ask what would change. On the last day, his parents give him an extra $10 for being such a good boy. So write the new function. So let's look. On the first day of the month, doubling his money each day for the entire month. So that means each day his money is going to be modeled by this. Now we're saying not at the end of each day, but just after the whole thing's done, we give him an extra $10. Okay? So this would be another way of saying this, or another similar model would be, what if he already had $10 in his account? His parents are not doubling the $10. Right? The $10 is not affected by time. It's just at one time. So our new function is going to be 5 times 2 to the t, exactly what we had before, plus 10. So the new function, we need to graph this on the same axis to the left. That means that we're going to add 10 to every single point. So look, here's a point. We're going to add 10. Here's a point. We're going to add 10. This is halfway between. Right? 5 times 2 to the t would be if our y-intercept here is 5. So this is going to be 15. It looks like we're at -1. We should be at 2.5. That's about right. So we're going to go up 10 here. And we're going to say that's about right there. Okay. Notice that it looks like it's getting closer, but that's because our eyes are measuring closest distance. What we need to be focusing on is vertical distance. Okay? So vertical distance means it's looking like this. And what's it going to flatten out to? Well, it's going to flatten out to the $10 that he gets automatically at the end. So what this did is this moved all points, or moved the function up 10 spots, or vertically by plus 10. That's all it did. Okay? It did not change the steepness of the curve. If we take this and we move it up 10, it does not change the steepness. So look, see, this is 10 from here to here. This is 10 from here to here. So we just moved it up 10. Identify whether the functions represent exponential growth or decay. Okay, so remember, growth or decay, that question is whether it's getting flatter or it's getting steeper. Are we getting closer to a number, or are we getting further away? Are you getting closer to infinity? And the way I determine that is the number that we multiply by over and over and over again. So this is times 3 times 3 times 3. You can see that by multiplying by 3 over and over again, we're getting further and further away from 0. We're getting larger and larger. So this would be growth. This one, times 1.8 times 1.8 times 1.8, it's just barely over 1, or 1.08. But it is over 1. So these numbers are going to be getting larger. Now they're going to be getting larger in the negative sense, so they're going to be getting more and more negative, but they're not getting closer to 0, so this is also growth. This one, 0.86. So if we multiply something by 0.86, that's 86%. So that means we're getting smaller and smaller and smaller. So this would be decay, because 0.86 is going to shrink this closer to 0. Same thing here. We have the common factor multiplying by 4 over and over and over again. So even though we start by 2 at 2/3, multiplying by 4 means it'll be 8/3, and then 8 times 4, 32/3. We're getting larger and larger and larger. So this is growth. And one more, a decimal or less than 1 as our common factor. This is decay. All right. Number 9. Below is a sketch of an exponential function. So we're trying to fill out what would a possible function be. So I could see this is decay, which means I'm getting closer to 0. So that means this must be less than 1. What that is, really, could be anything. You know, I'll just say 0.5. Here is my initial value, and my initial value is positive. So this must be positive. We're given no scale here. So we don't know if this is 100 or 1,000 or 0.5, but we do know it's positive because it's above 0. I'll just put 10 because that's a positive value. But again, lots of possible answers. We're asking you to make the connection between the shape of the graph and say, oh, because it's shaped like this, that must mean I've got a positive initial value and a fractional or a decimal common factor. All right, and last page, another thing about graphs. Last bit. Match the functions with their graph. So I can see this is growth, and I can also see, if I look carefully, look, this is not approaching 0, but this is approaching, f of x approaches 150. So this must mean I have a constant here, or excuse me, not 150, 100. 100. Okay, so this is going to be e because I've got an added constant. So that means no matter how small this gets, no matter how small this gets, I'm always going to add 100. Here's a growth function. So this is growth. Here's growth. Here's decay. Here is growth because I'm getting further and further away from 0. And here's decay. Okay, these are negative initial values here. So I'm going to look here and say, oh, look, I've got 2 negative initial values. One of them's growth, one of them's decay. There's my growth because it's 2, and here's my decay because it's 0.2. So this must be A, this must be B. So I've got A, B, and E taken care of. Now I'm looking at a growth or decay function and a positive initial value. So I can see that here's my decay because it's 0.02 or 0.2 instead of a whole number 2. So this is growth. So therefore this is D here, growth, and this is going to be C. So process of elimination. All right, there's your review. If you have been doing your homework, or if you're cramming to do it now, all that stuff will build into that. And I believe in you, and I hope you work hard so you can do well on the test. Bye.